Welcome to a new test and teardown video. This time it's a Tektronix 620 monitor. So it's an XY scope and they're using their super nice large scope screens. So I expect this to give a beautiful picture. It is very big, and it is of course in mint quality and condition, and that is because it was never used, never installed. Look at that. It is in its original cardboard ready to install case. How is that possible? And it was found together with all the manuals and material. I mean, how can you, by the way, have that much material? That one is thick. Well, okay, operator's manual. I understand this is not super complicated stuff. So it's about 1980. So of course, just to how to use it. It is not a great big thing because we only got those 4 knobs where you can dial the screen up and down, left, right, intensity and focus. So what else do we really need to know about this? Yes, we need to know about the input level. So adjustable 0.8 to at least 1.2 volts. See, there is no amplify. It's only up, down, left, right. So that is how that is. And then, oh yeah, of course it is not inverted or anything. So positive signal goes up and positive signal goes to the right. Fantastic. That is exactly what we want. There was yes, here it is, 2 megahertz. So that is great for all sorts of XY scoping and stuff that I will love to play with. Maximum non-destructive plus minus 25. Wow. We're of course not going to do that. Crosstalk, linearity. I mean, this is of course Tektronix, right? So it's just all the fancy specifications and all the goody things. Ooh, the Z-axis amplifier, 5 megahertz. So yes, definitely we can do all sorts of cool things with that. And yes, here is the screen area, 10 by 12 centimeters. And it's 12 kilovolt. Okay, phosphor. With option 76, whatever that means. Yada, don't know that. Oh, by the way, power source. See? Oh, I gotta show you something. I did a fast inspect before I started the video, so I'm not super surprised to see this. But when stuff is for 120, that tells me it was never ever connected or anything like that. But I am a little bit worried to see a local type of connector at the end of the cable. So this one together with a non-modified input. See why I get scared now? Somebody may have plugged this in and everything is blown up and then put to rot in a cellar, and then 30-40 years later, yes, actually 40 years later. Oh man, it's 43 years later. It is now on my table. Oh yeah, you gotta see this is the instruction manual. Look at all that. What the heck? But that's because it's also a full technical with all the stuff. I did a very fast browse around this there was a chapter about the input voltage, how to do the input voltage. So I need to do that. Oh my god. All the schematics, all the details, all the... Oops! Yeah, here's the block diagram. How lucky is that? And that is how simple an XY scope really is. Just 2 analog inputs, deflection amplifiers, going to deflection, whatever type that is. In this case, it's electrostatic, of course. But it could have been something else. TTL input, and then an analog brightness input. And this is, of course, amplified and controlled into the high voltage supply, because that goes into the end of the CRT that will control the brightness. And of course, there's a power supply that will do all the low voltages and a few high voltages for both for deflection, but also the 12 kilovolts, of course. Or the classic American disclaimer. Ooh, unless you are qualified to do so. I hope so. I don't know. Maybe a little bit of luck. So here's the voltage selection kind of stuff that I need to figure out. And here is the instrument. And it is in that side. So this is my mains input. Blah, 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 blah. It will be in this area. So all I have to do is follow the on-off stick to the switch. And it's supposed to be in this area, right? And here it says... something about the input voltages, and that is all fine. Let's open and have a look. Sometimes it is a little bit scary to open stuff like this and see what kind of funny history is behind this. I mean, everything looks really, really nice and beautiful. See, that is the 2 input deflection amplifier boards. In here is some power entry stuff, and that will be all my adjustments. There is an extra fuse and an extra voltage selection plug here. And then you're going to see something that made me a little bit worried. That. What kind of funky stuff is that? What are they doing here? So somebody blew a fuse and then they added a new fuse on top of that one instead of buying the correct fuse. Okay. And what are they doing?
So somebody didn't read the manual.
No. And ooh, that is some yummy dust. We got tested by Kevin. Good old Kevin did the testing. Isn't that cute? It's written on the CRT. Oh man, that is beautiful. That is okay. That is the fuse. Nicely. Oh, that is nice rubber. Good quality. Oh, that. Can you hear that? Oh, yes. Oh, don't you just love Tektronix? Those CRTs are just so fantastic. And you can see the direct entry to deflection plates that's done here on the side, directly where they need to be, instead of pulling the signals all the way down to the bottom where all the slow speeds CRTs are doing it. And this is of course a full length CRT. Look at that monster. But that is how you make a good picture. Oh, so this is high voltage regulation resistors and stuff like that. And that is definitely the high voltage transformer and a little triple rectifier thingy here, right? That is a normal mains frequency transformer. Yeah, I have to go in here and have a look. I believe the voltage selection is in here somewhere. So how do I get in? Only those 2 screws? Okay, easy, easy. I'm still puzzling a little bit around with the voltage selection here. And I actually did find this low, mid, high. And as you can see here, there's a plug with 2 little cables. And that is the one that you move back and forward. So let me show you how it looks like in the unit. So here's another type of plug, and that looks a little bit red. It was probably red 20 or 40 years ago, right? So here we go, low, mid, high. So this is how you adjust, fine-tune the voltages, and it is now in medium, and it is like really loosey-juicy here. It's probably just held in place by this metal shield. And so that one is the red one, right? And there's also one that is maybe a little bit brownish, and it is not labeled in any way. And that is the alternate selector block. And that is kept here, so it's not going to get lost. And that one got 2 wires. So you need to read the manual to figure this out. It says the brown plug for 120 and the red plug. So it was the correct block, and it was set for medium. So I am perfectly fine. So I feel lucky. Let's try and power this on. Mains is applied. Oh, did I forget to push the magic switch all the way down there? 24 watts. So that is not too bad. I will crank down intensity. No, we actually got a picture. And it doesn't focus. How is that possible? Did I swap? Ooh, I need to adjust the gain. Hang on a second. See, that was easy. I did, of course, swap X and Y. Man, that is embarrassing. I should have done it right. But this is the thing that I just do. I just fool around, and you will get this into the video. I will not rewind and redo. So that is how it is. Man, that is annoying. I would have loved it to be correct if only I cared to do it right. So, but the picture here is just really sharp. Oh my god, there's a little bit of contact. Oh, see, it's already doing its thing. But I bet you can see the dots, and it is really good and sharp. You see the rounding errors, or this is actually the resolution, because it's only 8 by 8 bits. So I can't really pick a super high resolution analog voltage or the correct point. There's only a little bit too little or a little bit too much. So that's just the way that it is. But it definitely works, and it only uses 24 watts. Let's see if there's, yes, 23. So there's, and if I crank it up, it's 26. Wow. It's really bright. I gotta show you this. It's really not often that I find this kind of errors in Tektronix manuals, and it's not that often that I sit and have a blast about reading those manuals, but they are like really beautifully made. All those sexy details and all those beautiful drawings they have made, it's just amazing. But look, here is the power supply. Let's look here at the same time, right? So here's the side board, right? This is exactly what we are looking at, okay? Anode lead that goes to the CRT base pin socket. Duh, that is wrong, my friend. That is now not how it is in reality. Let me show you how it is in reality. So that is the cathode stuff that goes to the back. The anode lead is very, very different. It comes from the doubler, tripler, high voltage stuff, and the anode lead goes to the top of the CRT, or to the faceplate of the CRT. That is the anode connection. Ha! That is a little bit funny. And there is no anode lead. There is nothing shown here on this picture about that. So it's just a little funny thing that I find. And to go into super detail about the amplifiers and all that, but here's the deflection input, and then it goes to a dual JFET, and then the rest is just classic transistors, and that is driving the deflection, right? So if you look at the schematic, this is exactly how it looks like. That'll be the two wires to the deflection plates. That is the input, and here's the dual JFET in one little package, and that is of course the position that is on the it is located here, right? Got some overload protection here, so that is all nifty. So yeah, and the other one is exactly the same. This, I just wanted to keep the schematic in here because that is the usual stuff that people will break by overloading the input, or if there's an arc, or if it's running too hot or something like that, or too fast for too long time. And it is really tiny little transistors, and of course I've seen many deflection amplifier errors, so that is nice to have the schematic here. So here's the high voltage board. That is actually this one here in the middle, and I just wanted to give you my best of luck to the day that one of these are defect and you need to repair it. It's a little bit annoying with stuff that is self-oscillating, and this is definitely how this thing works, by a self-oscillating transistor and the windings here of the transformer. But then there's also a little amplifier here that measures the output voltage, and then it regulates via this transistor how much power this transistor is getting. So that means it's of course a regulated high voltage system. So all that is super fine as long as it's working. It can be a little bit tricky to fool around with self-oscillating power supplies. I prefer the one with a little IC that regulates or handle the pulse width modulation and the fixed frequency or variable frequency and all that kind of stuff. It's super easy to repair. But of course this is also very, very simple and very, very cheap and very low power and all that kind of stuff. So no need for it to be any more complicated than that. Oh yeah, by the way, the funny wire you saw earlier in the video, that is of course a trace rotation, and it's done entirely just by a positive and negative 15 volts and a little trimmer. And then if this is exactly in the middle, that means you have 0 volts, exactly 0 volts here, right? But you can go positive and negative, so that is a little bit of DC current that goes into those windings. Let me show you the wire if you missed it. So here is the trace rotation trimmer, but I think the wires here, that's just super nicely coiled up like that. So cute. Anyway, that was more or less all I wanted to show you guys about this really nice Tektronix. There's not a lot technology or funky features or anything inside this box really, so I can't talk about this for a million hours really. I just wanted to show you, yeah, all there is about it. See, date code 80. So this unit is from 1980, yeah, and brand new, yeah. Nah, it looks like it was used a little bit because of the funky fuse replacements, but other than that, Don't really see any signs of use. Oh, look at all those stickers on the CRT. That is amazing.